Okay, so let's continue on section 3.3 about the properties of a logarithm. So in this particular section, we will talk about change base formula to rewrite and evaluate logarithmic expression. We're going to use properties of logarithm to rewrite logarithmic expression, and we use the properties of logarithm to expand or condense logarithmic expressions. First of all, let's look at change of base formula. So for example, like log AX. Since in the calculator or in the Excel or any like online platform, there's only two bases, either base 10 or base E. So typically you would turn the logarithm into base E, ln of x over ln of a. Or turn into log with the base 10, log of x over log of a. Okay, and that's basically how we convert in the logarithmic other than base e or base 10 to the proper form. And since most calculators only have two types of log keys, one is for common logarithm base 10, the other one is for natural logarithm base e. So typically when you get something other than 10 of e, and then you get a change of base. So change base formula. So basically log ax could be, if you want to turn into base b, any base, right? It will be log bx over log ba. Okay. If you turn into log with base 10, so log ax would be log x over log a. If you turn into base e, the log ax would be ln of x over ln of a. Let me give you an example. Let's say we have a log 2x, right? So you can either turn it as ln of x over ln of 2, or you could turn into log x over log 2. Okay. So now one way to look at a change of base formula is logarithm base A is simply constant multiple of logarithm base b. Okay. The constant multiplier is 1 over log base ba. So now let's take a look at the example. Changing base is common logarithm. So log 25 you could turn into log 25 or log 4. Okay. Then you put into the calculator to get the result. Log 25 over log 4. And that turned out to be approximately 2.32, 192. A095. Okay, so also you can change the base to ln, so log 425. You can write it as ln of 25 over ln of 4. If you put it into the calculator, you get exact same thing. Okay, same result, no difference. So either way you like to convert it before you can get a result. Let's take a look at property of logarithms. Okay. You know that from preceding section, logarithm function with base A is inverse function of the exponential function. We talk about inverse relationship between the logarithm and the exponential function. So it makes sense that the property of exponents should have corresponding properties involving logarithm. For example, a raised to u power times a raised to v power becomes a times a raised to u plus v power. Okay. So log a uv, you have a product of two logarithm of two expression. So then you can split up into two logarithm, log au plus log av. So we have following three properties. First one is called product property. So you have a product of u and v. You split up into logarithm of two expression, and then you sum up them, right? Ln of uv, same thing, Ln of u plus Ln of v. The quotient property, log a u over v should become, the quotient becomes a difference, subtraction in between. So log au minus log av. Ln of u over v is Ln u minus Ln v. Power property, that's the third one. A log a u raised to nth power becomes the power goes in the front, becomes coefficient n times ln a log of au. Ln of u raised to nth power, again n goes in the front, n times ln of u. And then that's, so similarly you can move in backwards. If you want to go back to this, right, you can move in backwards in order to condense the logarithm. So you work from either direction. Okay. If you want to condense the logarithm expression, then you're moving backwards. Okay. Now let's take a look at an example. Let's say you want to write each logarithm in terms of ln of 2, ln of 3. So part A, since we know 6 equals 2 times 3, so now using the product rule, product property, it becomes the sum of 2 ln, right? Ln of 2 plus ln of 3. They both is expressed in ln of 2 and ln of 3. And similarly, to the second one, the division will become subtraction. So ln of 2 minus ln of 27. So we already have ln of 2, ln of 27. You can turn it as 3 to the third power. So now using the power property, then 3 goes in the front, 3 times ln of 3. Okay. So it will be expressed in terms of ln of 2 and ln of 3 using couple properties. And sometimes we need to rewrite a logarithm expression, meaning we need to expand it. Okay, so we use the above 3 properties: product rule, quotient rule, and a power rule to convert complicated products, quotients, exponential form into simpler sum difference products, respectively. Now let's first of all look at this. Let's say we have a pallet. Okay. If you have log base 4 and then it's 5x cubed y. Now according to the product rule, it should becomes the sum of 3 different logarithms of base 4. Log 4y. Okay. So now if you want to simplify further, for the second one you put a power in the front, so it's log 4 5. Plus 3 times log 4x, adding log 4y. So that in that case you expand it completely, right? So expand it completely. And second one, ln of part B. So the division becomes subtraction. Ln of 7. And now ln of radical square root of 3x minus 5 will become 3x minus 5 raised to the half power. So you turn radical into exponent. Now you put the power in the front. It's half times ln of 3x minus 5 minus ln of 7. Okay. And that's how you expand it completely. So if you want to condense it, you go moving backwards, right? Backwards to the single logarithm expression. So you can move in backwards to single logarithm expression. Now let's take a look at, yeah, we did this already. So now let's look at how to condense the following logarithm expression into single logarithmic expression. So again, first of all, we're gonna going backwards, meaning all these, the difference, the sum. So if you want, you can put a sum together, plus 5, rearrange those two, log x plus 2 minus 4 times log x minus 1. So now it'll become, so put back the coefficient as the power. So going backwards. n minus log x minus 1 to the 4th power. Okay, now eventually the addition will become product, the subtraction will become quotient. So on top we get x plus 1 to the 3rd power times x plus 2 to the 5th power, and dividing by x minus 1 to the 4th power. Okay. If you want to put it into the square bracket, you could do that. Yes. So that's how you condense the into a single logarithmic expression. Similarly, for the second one, first of all, let's put back the coefficient as the power. Okay, so one ln of y to the 1/3 minus ln of z to the quarter. Okay, now addition becomes multiplication, so ln of x to the half times y raised to 1/3 over z to the quarter. And typically this is good enough, but if you want to write it as a radical, so you can do that as well. So this is perfect answer. But you can also write it as a ln of radical x plus times cubic root of y over 4th root of z. Okay, so either way is good. Either answer will be good. I think that's pretty much for the section 3.4.